Okay, sir. This lecture we are going to see one-dimensional wave equation in applications of partial differential equation. Type 1 problem. First, a uniform string is stretched and fastened to 2 points L apart. Motion is started by displacing the string into the form of the curve y is given. So, y means the displacement is given and then released from the position at time t equal to 0. Initially t equal to 0, derive the expression for the displacement of any point of the string at a distance x from one end at time t. So, given actually 2 points, you have to fix x equal to 0 and x equal to L. So, first you have to consider one-dimensional wave equation. One-dimensional wave equation is dou square y by dou t square equal to a square into dou square y by dou x square, where a square is tension by mass. Next, you have to consider the correct solution of one-dimensional wave equation. The correct solution of one-dimensional wave equation is y of x comma t equal to a cos px plus b sin px into c cos pat plus d sin pat. You have to consider this equation is number 1. Next, you have to consider the boundary conditions. Boundary conditions are, first one you have to take y of x comma 0 comma t, because the solution is y of x comma t, you have to calculate. Initially it is in rest, so that is why you have to take x in the place 0. So, y of 0 comma t value is 0. Next one, second one, y of L comma t, length is L here, so y of L comma t value is 0. Third one, dou y by dou t, velocity is not given at initially, that is why dou y by dou t at x comma 0 equal to 0. Fourth one, displacement is given at time t equal to f of x, it is given k into kx into L minus x, that is k into Lx minus x square. So, initially you have to consider the boundary conditions. First one you have to take y of 0 comma t, because initially at 0. Next one, y of L comma t also 0, velocity is not given, that is why you take 0. Displacement is at time t equal to 0, it is given, so you have to consider the function kx into L minus x. Next, you have to substitute the boundary condition one by one here. First boundary condition is y of 0 comma t equal to 0, x in the place you have to substitute 0. So, if you substituting first boundary condition in equation 1, x in the place if you substituting 0, you will get a into cos 0 plus b into sin 0 into t term you have to consider as it is. So, c cos pat plus d sin pat. By the boundary condition it is 0, that is why you have to take y of 0 comma t value is 0, cos 0 value is 1, so a, sin 0 value is 0, so a into c cos pat plus d sin pat. So, a into c cos pat plus d sin pat value is 0 means one possibility, one value is 0. Two possibilities here we have, either a equal to 0 or c cos pat plus d sin pat value is 0. Suppose C cos PAT plus D sin PAT value is 0 means if you substituting that value in the correct solution, you will get y of x comma t becomes 0. So, it is a trivial solution, that is why C cos PAT plus D sin PAT value is not equal to 0, since your y of x comma t value become 0. Therefore, only one possibility is a value is 0. So, substitute a value, substitute a equal to 0 in equation 1. If you substituting a value is 0 in the correct solution, your correct solution become y of x comma t equal to b into sin px into c cos pat plus d sin pat. So, now this is our correct solution. So, you have to mark this reduced correct solution as equation number 2. Next, you have to substitute the second boundary condition. Substitute second boundary condition in equation 2. Y of x comma, your boundary condition is L comma t. So, x in the place you have to substitute L. X in the place if you taking L, it become b sin PL into c cos PAT plus d sin PAT. By the boundary condition, your y of L comma t value is 0. So, 0 equal to b sin PL into c cos PAT plus d sin PAT. So, here we will get three possibilities, either b equal to 0 or sin PL is 0 or c cos PAT plus d sin PAT value is 0. Already we have seen c cos PAT plus d sin PAT value is not equal to 0 because of your trivial solution y of x comma t become 0. So, next one b equal to 0. If you substituting b equal to 0, already it is in multiplication. So, if you substituting b value is 0 in the correct solution, you will get y of x comma t tends to 0. That is why only one possibility is sin PL value is 0. So, b value is not equal to 0. C cos PAT plus d sin PAT value is not equal to 0 because of since your y of x comma t equal to 0. So, therefore, only one possibility is sin PL value is 0. So, sin PL value is 0 means we can equate this 0 is as sin n pi, because sin n pi value is always 0. So, sin PL equal to sin n pi. So, we can take what is PL, PL equal to n pi. We can calculate what is the value of P, it is n pi by L. Now, substitute your P value in the previous correct solution. So, substitute P in equation 2. So, your y of x comma t become b sin n pi x by L into c cos n pi at by L plus d sin n pi at by L. So, after substituting your p value, you have to take this one as our correct solution. So, you have to take this is within the box and mark it as equation number 3. Next, you have to substitute the third boundary condition. Third boundary condition is dou y by dou t. Dou y by dou t means you have to differentiating partially with respect to t in this equation. After that only we can substitute the boundary condition. So, substitute first you have to take differentiating partially with respect to t in equation 3. So, if you differentiating partially with respect to t, it become dou y by dou t of x comma t equal to partially with respect to t means you have to consider x as a constant term because it is partial differentiation. So b sin n pi x by L as a constant term, so you have to keep as it is, into c differentiation of cos term is differentiation of cos x is minus sin x, differentiation of sin x is plus cos x. So differentiation of cos n pi a t by L become sin n pi a t minus sin n pi a t by L into your t coefficient. Actually differentiation of cos ax value is minus sin ax into a. So x coefficient you will get in the multiplication. So here cos becomes sin n pi a t by L into t coefficient you will get in the multiplication. So n pi a by L plus d into sin differentiation is cos. So cos n pi a t by L into t coefficient is you will get in the multiplication n pi a by L. So you have to differentiating partially with respect to t in the previous equation. Next one, now substitute your boundary condition. Substitute your third boundary condition in the above equation. So third boundary condition is dou y by dou t at x comma 0. So t in the place you have to substitute 0. T in the place if you substituting 0, it become b sin n pi x by L into minus c into sin 0 value is 0. So d into cos 0 value is 1. So d into n pi a by L. So t in the place if you substituting 0, you will get sin 0 value is 0, cos 0 value is 1, sin 0 value is 0. So totally it becomes 0, cos 0 value is 1, that is why d into n pi a by L. By the boundary condition it is 0, so 0 equal to b sin n pi x by L into d n pi a by L. So here we have 4 possibilities for 0, b value is 0 either, or sin n pi x by L value is 0, or d value is 0, or n pi a by L value is 0. Already your correct solution is in multiplication we have b into sin n pi x by L. So b value is not equal to 0, sin n pi x by L value is not equal to 0, then n pi a by L is not equal to 0 because here every term is constants. So all are constant, that is why it is not equal to 0. For this one already we have seen your y of x comma t tends to 0. That is why b not equal to 0 and sin n pi x by L is not equal to 0. And n pi a by L value is not equal to 0 because everything is a constant term. N equal to, we can take n equal to 1 to 3 etc. L is the length of the interval, pi value is already we know, a also constant term. So everything is constant, that is why n pi a by L value is not equal to 0. That is why only one possibility is d value is 0. Therefore, d should be 0. Now substitute your d value in previous equation, equation number 3. So your correct solution become y of x comma t equal to b sin n pi x by L into d value is 0, that is why remaining value is c into cos n pi a t by L. Now this is our correct solution. So here b and c is the constant term, that is why you have to substitute, instead of bc we can take bn. So your y of x comma t become bn sin n pi x by L into cos n pi a t by L. Before substituting the last boundary condition, you have to consider the most general solution. So, you have to take consider the most general solution. The most general solution is, you have to consider the solution for summation n equal to 1 to infinity Bn sin n pi x by L into cos n pi at by L. So, this is our most general solution. So, you have to consider this one as our correct solution now. So, take equation number 4. Now, substitute the last boundary condition. Substitute the last boundary condition in equation 4. Last boundary condition is y of x comma 0. T in the place you have to consider 0. Y of x comma 0 become summation n equal to 1 to infinity Bn sin n pi x by L. Cos 0 value is the t in the place, if you are considering 0, cos 0 value is 1. So, Bn sin n pi x by L equal to f of x. Your f of x value is already we have k into kx into L minus x, or we can consider it as k into Lx minus x square. So, summation n equal to 1 to infinity Bn sin n pi x by L equal to k into Lx minus x square means you have to equate these two. So, by expanding this one, already in the left side we have a half range sine series form. That is why you have to expand our f of x by using half range sine series. To expand f of x by using half range sine series. Already we know the half range sine series. Your half range sine series is, that is f of x equal to summation n equal to 1 to infinity Bn sin n pi x by L, where Bn value is 2 divided by L integral 0 to L f of x into sin n pi x by L into dx. So, here f of x value is 2 pi L into, already your f of x value is kx into L minus x. So, k is the constant term, we can take k as outside 2k by L integral 0 to L, your f of x value is Lx minus x square into sin n pi x by L into dx. So, next you have to integrate this function. Here we have two functions in x, that is why we cannot integrate this one as directly. So, you have to apply Bernoulli's formula. Bernoulli's formula is integral u dv value is uv minus u dash v1 plus u double dash v2 minus u triple dash v3 etc. So, first you have to consider this function as u, a remaining function as dv. So, u value is Lx minus x square, dv value is sin n pi x by L into dx. So, first you have to integrate dv. If you integrating sine, integration of sine value is integral of sin ax dx value is minus cos ax divided by a. So, integral of sin n pi x by L value is minus cos n pi x by L divided by x coefficient you will get in the denominator. So, n pi by L. In the next step you have to differentiating the left side function. If you differentiating u, it become u dash. Differentiation of Lx minus x square is L minus 2x. Integral of v value is v1 equal to minus, already you have integral of cos value is sin, integral of cos ax dx value is sin ax divided by a. So, minus sin n pi x by L divided by n pi by L. Already you have n pi by L, that is why it become n square pi square divided by L square. Next you have to differentiating u dash. If you differentiating u dash, it become u double dash. So, differentiation of this one is the differentiation of L minus the 2x value is the differentiation of L is 0 minus the 2x the differentiation is minus 2. Integration of V1 is V2 minus sin integration is minus cos, already you have minus symbol, that is why it become plus cos n pi x by L divided by, it become denominator become n cube pi cube divided by L cube, because you will get n pi by L, already you have n square pi square by L square, that is why it become n cube pi cube by L cube. If you differentiating u double dash, you will get 0, that is why you have to consider up to this one. Now substitute all the values here. So, your Bn become Bn equal to 2k by L into, first one you have to take u into V value. So, u value is Lx minus x square into V value is minus cos n pi x by L divided by n pi by L. In the formula you have minus symbol, that is why minus. Next term L minus 2x into minus sin n pi x by L divided by n square pi square by L square. Next in the formula we have plus symbol, so plus L minus 2 into minus cos n pi x by plus cos n pi x by L divided by n cube pi cube divided by L cube. So, overall the limit is 0 to L. Now, substitute x in the place your upper limit and lower limit. If you substituting x in the place L, L into L become L square minus L square becomes 0. So, if you substituting upper limit in the first function, it becomes 0. If you substituting lower limit 0 x in the place, it becomes 0. So, totally the first term becomes 0. In the second one, if you substituting the upper limit, it become L minus 2L, L minus 2L become minus L. But here if you substituting L, L get cancelled, you will get sin n pi. Sin n pi value is always 0. Sin n pi value is always 0. So, if you substituting the upper limit, the second term becomes 0. If you substituting the lower limit, sin 0 also 0. So, second term also get cancelled because it becomes 0. So, you have to consider only the last term 2k by L into, you have to consider the constant term as outside. So, minus 2 L cube divided by n cube pi cube into, if you taking x in the place L, it become cos n pi minus, if you taking x in the place 0, it become cos 0. So, L and cube get cancelled, it becomes square, it become minus 4k L square divided by n cube pi cube into cos n pi value is minus 1 the whole power n minus cos 0 value is 1. Sin n pi value is 0 and cos n pi value is always minus 1 the whole power n. So, if you multiplying by minus, it become 4k L square divided by n cube pi cube into 1 minus minus 1 the whole power n. So, within the bracket we have 1 and minus 1 the whole power n. So, your Bn value is, we have 0, when if you considering n in the place 2, it become minus 1 the whole square, it become plus 1, 1 minus 1 becomes 0. So, if you considering n in the place 2, 4, 6 any even value, your Bn value becomes 0. So, you have to consider two cases Bn value is, first you have to take when n is odd. When n is odd, if you substituting n in the place 1, it become 1 minus minus 1. 1 minus minus 1 become plus 1. So, minus of minus become plus, it become 2. 2 into 4 become 8. So, 8k L square divided by n cube pi cube when n is odd. If you substituting n value as any even value, n in the place 2 for example. So, 1 minus minus 1 the whole square become plus 1, 1 minus 1 becomes 0. So, 0 into anything becomes 0. So, your Bn value becomes 0 when n is even. So, therefore, your capital Bn value is small bn, because already Bn sin n pi x by L we have, that implies Bn value is same value 8k L square divided by n cube pi cube when n is odd. It is 0 when n is even. Now, substitute your Bn value in the correct solution, most general solution. Substitute your Bn in most general solution. So, your y of x comma t become summation, usually summation n equal to 1 to infinity we have to consider, but when n is even your capital Bn value is 0. So, no need to consider the even values. So, you have to take only consider the odd values, n equal to 1, 3, 5 etc. up to infinity, your value is 8k L square divided by n cube pi cube into sin n pi x by L into cos n pi at by L. So, this is our most general solution. Suppose if you are having, this is the first problem, okay. Next one, முடிஞ்சிருச்சு சார்.